Let's start with the bug. A user asks, "Can I get a refund after my annual plan renewed last month?" And the cache replies, "Yes, cancel your free trial anytime." Here, fast answer, wrong user, wrong policy. That is a dangerous version of caching an LLM. Now, why would anyone build a cache like that? Because at high level, the support bot has a very real cost problem. Every request sends the same policy docs, same tool definitions, same examples, and then one small question from the user at the end. After some traffic, this starts looking stupid. The model keeps reading the same long prefix again and again, and we keep paying for that. So the obvious engineer reaction is okay, cache it, right? Why are we calling the model every time? But with LLMs, that one word, cache, hides two completely different things. One cache reuses the work of reading the prompt. The model still answers the actual request. On the other cache reuses an old answer and can skip the expensive model generation much faster. But now your cache can lie. That is a whole thing. So, what went wrong there? A normal cache is exact key, exact value. Same key comes in, same value goes out. But an LLM call has two different things inside it. There is giant prefix, which includes instructions, docs, tools, all that. And then there is a user question. The prefix problem is, why are we making the model reread the same 10,000 tokens every single time? Tokens are just pieces of text, right? And the model still has to process each piece before it can answer. That repeated reading is waste. The question problem is different. One user says, "Can I cancel my trial?" Another says, "How do I stop my free plan?" Exact strings are different, but at a meaning level, maybe they are asking the same thing. So, there are two reuse opportunities: reuse the work of reading the repeated prompt, or reuse the old answer for a similar question. Only one of those is safe by default, that is the split. Let's start with the safer one, prompt caching. And the first thing to remove is a wrong mental model. Prompt caching is not, "I asked this question before, so give me the old answer." This is not what it is doing. Before an LLM writes the answer, it has to read the prompt. This reading step is usually called prefill. Plain meaning, the model processes the input tokens and builds the internal state it needs before generating output. So, if the first 10,000 tokens are identical across calls, prompt caching lets the provider reuse that processed prefix. Next call, the model does not start from zero for that same prefix. It can pick up from the cached state and then processes the new question. But notice the important part. The model still runs. It still sees the new user question. It still generates a fresh answer. So, prompt caching is not reusing an old answer. It is reusing processed input. That is why this cache should not change the logical request. If the prefix matches correctly, you are not asking a different question. You are just avoiding repeated input work. That is the most important part. Now, how do we use it properly? The rule is very simple: stable stuff first, changing stuff last. Put your system instructions, examples, tool definitions, and stable context at the beginning. Put the user question timestamps, request specific data, all moving parts at the end. Because the cache is matching a prefix. If you put a timestamp near the top or reorder tools every request, you are changing the beginning of the prompt, right? Then the provider can't say, "Yes, I have seen this same prefix before." It has to reread again. I wouldn't build the whole mental model around one percentage. Providers and model keep getting changed. The useful thing is simpler. Repeated input can get cheaper and faster. Output still has to be generated. So, if your prompt is large, stable, and reused, close together, I don't think there is much to debate. Use prompt caching. Structure the prompt properly, keep the stable part at the front, and the most of the win basically comes for free. Now, This is where it gets tempting. Prompt caching still called the model, it only made the call cheaper. But what if the question is basically something we have answered before? Can we skip the model completely? That is semantic caching. Semantic means meaning. We take the incoming question, convert it into an embedding, basically a vector, that tries to capture what the question means. Then we search previous questions we have already answered. If the new question lands close to an old question, we say, okay, this is the probably the same intent. Let's return the old answer. And when this hits, it is a much bigger win, right? No main LLM generation call. You may still do an embedding and vector lookup, but you skip the expensive answer generation. For any boring FAQ traffic, this can work like a charm. But see the word I slipped in there. Probably. Probably the same intent. That is where the whole problem lives. Let's make it concrete. At high level, our policy has two rules: free trial, cancel anytime before it ends, no charge. Annual plan, once it renews, no refund. Two different rules, two answers. Now, our cache has this old question: can I cancel my free trial? With the saved answer, yes, cancel before the trial ends. And a new user asks, can I get a refund after my annual plan renewed last month? At a surface level, these are close, right? Same words, cancel, plan, billing. But the answer is not the same. If the semantic cache says close enough, it can return the trial answer to the annual renewal user. Fast, confident, but wrong. And this is worse than a normal cache miss. A miss is just slow. A false hit is a product bug. The model never ran, so there is no second chance for the model to notice the difference. That is why the threshold is not just a speed knob, it's a correctness knob. If we lower it, we catch more questions, but you also risk more wrong matches. If we raise it, we become safer, but more requests fall through the model. So, semantic caching is not just switch it on. It is a decision about where being occasionally wrong is acceptable. For a repetitive FAQ, maybe yes. But for billing, medical, legal, user specific state, or anything that depends on right now data, I would be very careful. So, in a real system, I would not ask, should we cache the LLM? The question is too vague. I would ask three simpler questions. First, is the repeated thing an exact prompt prefix? If yes, use prompt caching. That is the clean one. Second, is the answer actually invariant and low risk? Same answer every time. And if it is slightly wrong, nobody gets hurt. Then maybe semantic caching is okay. Third, is it user specific, policy specific, or money related, or any time sensitive? Then let the model run. Maybe prompt cache the prefix, but do not blindly reuse an old answer. At high level, that is the mental model. Prompt caching saves the work of reading the prompt. Semantic caching saves the answer itself. One makes the same model cheaper, the other avoids the model call itself. But now your cache can be wrong. So next time someone says just cache the LLM, the first question is not which database to use. The first question should be, are we caching the work or are we caching the answer? Because those are completely two different systems.